Okay, guys, right. Question 4. Let's have a quick read of this one. So, some of you might have a little mild panic attack when you look at the equations, the first equation, but it's nothing too difficult. All right, so let's keep reading. The curve with the equation y equals 2 ln 8 minus x, all in a bracket, meets the line y equals x at a single point where x equals a. Okay, show that the solution A is between 3 and 4, basically, so that there is a root, or that the point where they intersect is between 3 and 4. So you can use the graph to see where this point is. It's here, isn't it? We're talking about here. And very kindly labelled 4 there as well. Okay, so we've got to show that this is between 3 and 4, let's say. So we've got to show that it's somewhere between 3 and 4. And all you need to do to find out where two lines intersect is set the two lines equal to each other. Alright, and then you can kind of like use that equation. So let's do the first one. So we've got y equals x and y equals 2 ln 8 minus x. We've got to set these two parts equal to each other, because they are, because y equals y, right? So we can put those two next to each other. So I've got 2 ln 8 minus x equals x. And if I rearrange it to get 2 ln 8 minus x minus x, move the x over, oh my god, I wrote an 8, minus x equals 0. Alright, so this equation, I'm going to show that there is a solution here. Okay, so I'm just going to sub in the two values 3 and 4, and we'll see what happens. We'll see what we get. So if we put in 3 first, should write that here. So that x equals 3 over here. Put it into your calculator, and you should get, I've got this saved, ready to go on my calculator. I'm getting 0.2188 something, something, something. Put in 4, x equals 4, pop that in, and we should end up with another result. And let me just scroll down. So this one says minus 1.22, that's a point by the way, not a comma, 7 ... So we've gone from a positive solution to a negative solution, and that indicates a root between the two values, okay, or a solution to our our intersection is between a and 3. That's enough. So change of sign indicates a root. Which it shows, it's evident that there is a root there. Okay. Now, why does it do that? If we set them equal to each other, rearrange the equation and set it equal to 0, why does a positive answer and then a negative one when we put in 3 and 4? Why does that show us that there is an intersection point here? Let me take you into the wonderful world of Desmos very quickly. All right, just very quickly. We're going to pop in here. So the red line is the natural log curve that we had. The blue line is the y equals x, and the intersection point, you can see, is in fact 3.156. Okay, so it is between 3 and 4. What I did was I set the equations equal to each other, and then I set y equal to 0. And you get this new green function here. Can you see this line here? This is what we do when we set them equal, set the functions equal to each other and rearrange it to get them, all on one side. And when y is 0, so we're talking about when does this cross the x-axis when y is 0, you can see, look, that the root is identical to the intersection point. So when I put in the value of 3, let's say, on this side, and I'm going to get a value up here, somewhere there, look, I'm going to get the positive 2.19, and when I put a value of 4 in, it's going to be below 0. So this new function, when you set it up like this, is perfectly showing you that my sign change indicates a root there, and is also perfectly in line with the original one. Alright, so this green line, all this is, when you set it up like this, is the difference, look, between the two functions. So the red line minus the blue line, whatever the values are, and obviously what is the value when they are bang next to each other? If you take away the red value from the blue value and they're on top of each other, the difference is nothing, it's 0. That's why the green line is plotting a difference of 0. If you go further up the curve, let's have a look at here, for example. Look, you've got the red line, take away the blue line. Well, the red line is something bigger than the value of the blue line. For example, what is it? It's like, let's say, it's like almost 2 take away, oh no, that's higher than that. What's the high value there? It's like 3.5 take away 2, which is going to be about, the green line will say it's about 1.5. So it's a clever way of doing it, and I wanted you to understand why that's happening. Because sometimes we just do things and we're not really sure the maths behind it, what's going on. So, very quickly, the last part B says, it's an iterations question, but it's not putting it into your calculator. In an attempt to find an approximate value for A, alright, a student uses the iterative formula, this formula here. And using the graph, normally you would put 4 into the formula, wouldn't you? And get another answer out, put it back in, get another answer out. We're not doing that. We've got to use the graph to determine whether or not this iteration formula can be used to find an approximation for A, justify your answer. So we're going to show graphically what we're doing when we put 4 into the graph, so into the calculator, sorry. So we put 4 in, and it will give you a value. Okay, it will give you a value of, we're using this curve, you see, look, 2ln 8 minus x. I put the 4 in there. What value does that give me? Well, that's going to give me, if I read off the value, here's the value here, the y value. That new value there is going to go back into our formula. Okay, so we're going to put this value in now into here, and we need to read off the original curve. So we're going to read up. Okay, so it's going to give us this. If we put this into our curve, what's that going to equal on this line here? Because remember, we're saying that we're setting them equal to each other. So then the new value would be, to read off, would be here. So I'm going to get a new value. Start again. Up we go. Read off here. So we're going to get a value there. And then we'll feed it. It's going to go back into the other one. And then it's a spiraling format here. Do you see? It's going to keep spiraling around and zooming in on the solution. So it's not going to diverge away. It is going to spiral around and give us better and more accurate approximations each time. I hope I've explained that clearly enough, but if you're not sure, then obviously that'll be something you need to go and look at, the iterative formulas, but using the graph to show the pattern that it makes.